Continuing with 4.2, 4.2b is in boy in elementary algebra, doing division with exponents, and we're going to do examples, numbers 14 through 19. It'll take a little bit of time, but I think that it'll be very helpful when you end up doing the homework here. So let's just start with 14 and work our way down. So we have 5x cubed, and that is to the second power, and that is over x to the fourth. Alright, let's see what we've got here. We're just going to do our numerator, and then we'll do our denominator and get everything simplified, and then we'll go ahead and divide across the line. So 5 times 5 is 25. That's what that squared is doing, 5 squared. X to the 6, 3 times 2, over x to the fourth. Now, again, we can look at it like I'd said earlier. I've got 4 x's there, and I have 4 there, and if I take all 4 of those, I have 2 left over. So my answer is 25x squared. Okay, so we canceled. Another thing you could do, instead of canceling, you could have written as 25x to the 6 minus 4. Numerator minus denominator. And we get 25x squared. Same thing. It's just whatever you feel comfortable doing is fine. It's basically the same idea. Alright, 15, we have x to the minus 8 over x squared cube. Okay, so we're going to simplify the numerator first, which we can. It's already simplified. Whoops, that is an 8. And the bottom is x to the 6, because we multiply, because there's the parenthesis between the 3 and the 2. Now we can write this as x to the negative 8 minus 6, or x to the minus 8, if this helps, plus negative 6, if it helps to add a negative instead of just subtract. So x to the negative 14 would be our answer there. Or if you want positive, because this is over 1, if you want your exponent positive, we move the x to the negative 14 down, the negative goes away, and we put a 1 on top. So either this answer or this one is correct. Continuing on with number 16, y to the 5th over y cubed, and we'll square that. Okay, and again, that squared means everything in the parentheses. So this is going to be squared, and that will be squared. So what we've got is y to the 5 times 2, because remember you multiply, and y to the 3 times 2. And because we're dividing, we get y to the 10th minus 6, y to the 4th. Or, like I said before, I'm going to take 6 of those, and I'm left with 4 there, and I get y to the 4th. Alright, let's jump down to number 17, and it gives us 3x to the 5th to the negative 2. Okay, so what is this negative affecting? Everything in the parenthesis here, because this negative, normally if there wasn't a parenthesis, it would just affect this x to the 5th. But since there's a parenthesis by everything, that negative affects everything here and the 2. So this whole thing is in the wrong place. So we can write it as 1 over that. We just move it into the right place. 3 times 3 is 9x to the 10th. Just like that. Alright, number 18. X to the minus 8 times x to the 5th equals x to the negative 8 plus 5 equals x to the negative 3. Or, because that's x to the negative 3 over 1, we can write it as x cubed, put it in the bottom to take away the negative sign, and get that for an answer. Okay, this is example number 19. A lot of stuff here. But if we just do what's in the numerator, then we do what's in the denominator, and then we cross the line once we get that together. Alright, so a cubed squared is going to be a to the 6th power. And let's leave this one alone for right now, the a to the negative 4th. And a to the negative 4 cubed. Negative 4 times 3 is negative 12. So see what we can do. We can multiply those two, even though one's a negative. This is going to be a to the 6 plus negative 4 because they're multiplied. When you multiply, you add the exponents. And this will stay negative 12. So this then becomes a to the positive 6 plus negative 4 would be a positive 2 over a to the negative 12. Ew, that still looks pretty yucky. So what I'm going to do is I'm going to do my division, and the division says that I subtract. So I'm going to subtract. I'm going to take 2 minus negative 12, which is the same as 2 plus 12, giving me that for an answer. So example 20 says, let's suppose we have two squares. One is bigger than the other. Okay, so there's my two squares. If the length of the side of the larger square is 3 times the length of the side of the smaller square. So we don't know anything about the small one, so we'll call it x. What do we know about the big one? The big one is 3 times. Okay? How many of the smaller squares will it take to cover up the larger square? Well, it's going to be the area that we're looking at. The area here is x squared. The area here is 9x squared. So this one is an x squared. That's how big that is. This one here is 9 of these little x squareds. So how many is it going to take to fill that up? It's going to take 9 of those x squareds. So pretty simple. Example 21 is the same thing, only we have our cubed here, and the length of the cubed is x, so x times x times x is x cubed. Okay, that's how much volume there is in that cube. And then we have a big boy here. And what do they tell us about that one? They say it's 3 times as long, 3 times as deep, 3 times as high. So that means this was 27x cubed. That would be the volume of the big one. That's the volume of the little one. They want to know how many of these will fit in there. Well, it tells you right there again, 27. Okay, just to continue on with scientific notation here for a minute. We had talked earlier about us having something like 570,000. Writing it in scientific notation, one number, decimal, then the next two numbers. In this case, the next one's a 0, so we really don't need to put it on there. And then we write it times 10, and we look at where we were with our decimal and where we ended up. So 1, 2, 3, 4, 5 places. So that's what the exponent is there, 5 places over. That's what the exponent does, is it tells you two things. It tells you how many decimal places to go over, 1, 2, 3, 4, 5. It also tells you what direction. This is a positive 5, so you go, we went from here to here, right to left. We went to the left 5 places. Okay? If we had a really, really small number, like a decimal point 0.00000567, we would do the exact same thing. The first number we come to goes to the left of the decimal, then 2 more numbers, times 10. Okay, now let's see what we've got here. This is where my decimal is. This is where it went to. So it went 1, 2, 3, 4, 5, 6 places over, but it went the other direction. Up here, we went from here 6 or 5 places to the left. Here we're going to the right, so therefore our sign is a negative sign telling us that we are going how many decimal places to the right. Okay, so that's it for 4.2 elementary algebra division with exponents.